Welcome back, all of my dearest viewers and my respected students. What are we are going to discuss in this session? In this session, I am going to discuss very important topics of community medicine. In every video, you tells it is a very important, very important. Okay, it's fine. So the name of topic is population attributable risks. What is the name of topic? The name of topic is population attributable risks. Okay, so what is the meaning of this population attributable risks? Let's see. Let's suppose in a city, what are happening? There are having exposure of what they are exposure of lead poisoning. So what happens due to the exposure of this lead poisoning? Now 60-17% the peoples in that city develops anemia. So here what I am telling to you, this attributable population attributable risks details that in a population, how many population, not in a population, in a city, how many population are affected by due to exposure. If we remove that exposure, then that percentage of no disease affected peoples get reduced. Okay, so we are again taking a beautiful examples. Let's suppose in a city a lead poisonings affected 16% of the population. So if I remove this lead metals poisoning, then the 16% peoples, I mean 16% peoples become disease free. So they reduces the chances of disease in a population. What I am writing in this boards, I am writing what I am writing in this board. In this board, you can see that population attributable risks. It tells how much population are affected due to exposure. Now, in simple terms, what I am saying to you, how much population are affected due to exposure. Exposure may be anything. It may be a smoking, it may be lead poisoning or some other things. So it tells that in a population, how much population are affected by due to exposure, and if we remove the exposure, that much percentage of disease in a population get reduced. For example, let's suppose in a village having 100 people, very small village and very less population, around 100. So in this 100 people village, 15 are smoker and 15 are non-smokers. So what happens in these 15 smokers, the 14 develops lungs cancer, and the 10, if there are 15 smoker, 14 develops lungs cancer, and 10 are the disease free. While in case of the non-smokers, there are 10 develops lungs cancer and 40 are the disease free. So on the basis of this data, we can formulate a tables. In table you can see that one side we write disease, non-disease and the total population. So a smoking is a exposure ARX factor. So in there are total 15 smokers. In total 15 smokers, 14 having a disease and 10 are the disease free. While in case of 15 non-smokers, 10 having disease and 40 are disease free. So what is the total number of people who having a disease? There are 15 who having disease, and there are also 15 who having no disease, and the total population is 100. So on this data we try to find attributable risks. Okay, so what is the formula of this population attributable risks? Before I am going to discuss the formula of attributable risks percentage, we first try to understand what is the meaning of this incidence of क्या लिखा हुआ है जी, incidence of disease in population. Okay, this is the full form of incidence of disease in a population. So incidence of disease in a population, how we calculate the incidence of disease in a population? For this we first calculate the total number of peoples in a population having disease, including both exposed and the non-exposed. So basically we try to find in a population how many peoples are affected by disease. So what we find, total 14 are a smoker who having disease and also 10 are non-smoker who having disease. So in a population how many total people who having a disease? 50, total 50 people who having disease. So we write this value 50 as above, and in denominator we write total number of population. So total number of population is what? 100. So this is the one data that we have to calculate. The second things what we have to calculate, second things we calculate incidence of disease in non-exposed. First we calculate incidence of disease in population, and the second we calculate incidence of disease in non-exposed conditions. So again incidence, so how we calculate this incidence of disease in non-exposed? We first calculate, that is how many non-exposed people who having disease. So there are 10 non-exposed people who are not a smoker that develops the lungs cancer, and total number of non-exposed people, that means what is the number of people who are not smoking. So this value is also 50. So on this data we again calculate some okay, so we putting these two data in the final formula of population attributable risk percentage. So what is the formula? Here we subtract the incidence of disease in population, that is 50 by 100, and the incidence of disease in non-exposed divided by incidence of disease in population. So when we calculate, the final value will come as 60%. For better understanding, we also take one more examples. Okay, so let's start. First, we try to erase my board. Okay, so I can write without erasing. How I can write in board? It is on board, not in board. You have to learn in this. Okay, I have to learn this. Okay, so now I am going to take one more examples for better understanding. So again we take not very large values. So because if I am taking a very large value, it is difficult to me to calculate. So that's why I take again very small village, very small village having a population of 100. Okay, so again in this 100 population, what happened? Now 10 more people I will increase. Initially in the first examples having 50 people who are smokers. Now we increase 10 more. There are 60 smokers. 60 are smokers, while the 40 are non-smoker. 40 are non-smoker. Okay, so what happened in 60 smokers? Again 50 of them develops lungs cancer and 10 disease free. Okay, so in non-smoker we take 10 develops lungs cancer, and what happens? 40 minus 10, that is 30. 30 are disease free. Okay, so on this first we formulate the tables, then I go for a calculation section. So in very beautiful diagram made by me. Okay, so here we write total population. Here this is free. Here exposed. Here non-exposed. Exposed means a smoker. Non-exposed means non-smoker. And total. So what we find according to this data, there are 60 smokers. So a smoker I mean exposed population is what, 60. Okay, so in 60 smokers, 15 of them develops lungs cancer and 10 are the disease free. What is the population of non-smoker? The population of non-smoker is 40. And in a non-smoker population, how many of them develops disease? 10. So how many remaining? 30. Okay, so what is the total value of disease person in a population? 50 plus 10, 60. Non-disease 13 plus 10, that is 40. And again total population is very simple, that is 40. Okay, so first we try to find incidence of disease in population. I mean in population, how many of person having developing disease divided by total exposed total number of population. So in population, how many of them develop disease? In population there are 60% who develops disease. Okay, what is the total value of population? 100. Okay, now we subtract the incidence of disease in non-exposed. So in non-exposed population, how many of them develops disease? In non-exposed population only 10 develops disease. Okay, and what is the total value of non-exposed population? That is 40. Then divided by again 60 by 100, that is the incidence of disease in a population, multiply by 100. Okay, so now how we calculate? It's me too difficult to calculate whatever the calculation that comes, that is the final answer. So by this way we can calculate the population attributable risks. Okay, thank you, welcome back in next lecture.